Hello there, welcome to another class. We're going to look at some questions on differentiations under the subtopic equation of the tangent, equation of the normal, and the stationary points. So we're going to start with a question, 2016 Kcse paper 1, question 10, and it reads: the gradient of a tangent to the curve y is equals to ax cubed plus bx at a point 1, 1 is minus 5. We have to calculate the values of a and b. So this question, we are going to first get the derivative. So the curve is y is equals to ax cubed plus bx. And we know that to get the gradient function, we differentiate our curve. So dy over dx is equals to 3ax squared, we drop 3, then we subtract 1, then plus b. So this gradient function is what that is giving us the gradient as minus 5. So we equate 3ax squared plus b is equals to minus 5. So that is equation 1. Then we need to have another case. We have this point. You have been told that at x is equals to 1. So what is that gradient? So we replace replace the values of x with 1. So 3a 1 squared plus b is equals to minus 5. So 3a plus b is equals to minus 5. Then we know that at any given point, this equation of the curve is going to make sense. So our curve is y is equals to ax cubed plus bx. Then we have a point 1, 1, meaning the values of y at that point is 1 and x is 1. So we replace those values. So we have a 1 cubed plus b times 1. Then we are going to have 1 is equals to a plus b. And this is going to be our equation 2. Where you have a plus b is equals to 1. And the other equation is 3a plus b is equals to minus 5. So we have the two equations, simultaneous equation. We solve them, and we can eliminate b by subtracting the 2. So we have a minus 3a, you get minus 2a. b minus b will be 0, so you are going to have eliminated that one. This is equals to 1 minus 5, you get positive 6. So you divide by minus 2 on both sides, and we are going to have our a being 6 divided by minus 2, you get minus 3. Then we get the value of b. You can use equation 1, that is a plus b is equals to 1. Our a is minus 3 plus b is equals to 1. We take minus 3 on the other side, it's going to be b 1 plus 3. When a number crosses the equal sign, it changes the sign. So 1 plus 3 is 4. So our value of b is 4. So that's how you can be able to solve that question. So we are going to look at question number 2. And this one is going to be question from the Kcse 2017 paper 1, question number 24. So the question says that the equation of a curve is given by y is equals to 2x cubed minus 9 over 2x squared minus 15x plus 3. So you're required to find the values of y when x is 2. Then the equation of the tangent to the curve at x is equals to 2, and also determine the turning points of the curve. So we start with the first one. We get the solution 1 to get the values of y when x is 2. So our curve is equals to y is equals to 2x cubed minus 9 over 2x squared minus 15x plus 3. So at x is equals to 2, we are going to substitute the values of y with 2, of x with 2. So you're going to have 2, then 2 cubed minus 9 over 2 times 2 squared minus 15 times 2 plus 3. So I'm going to have that one as 2 cubed is 8 times 2, you get 16. Then 2 squared is 4, then times divided by 2, you get 2, 9 times 2, get minus 18. Then 50 times 2, get minus 30, then you add 3. So this is going to be 16 plus 3, you get 19. 18 minus 18 minus that is going to be minus 48. And of course, 48, 19 minus 48, of course, 48 is greater than 19, so you get 19 minus 48 minus 19, but the answer is minus. So you get 18 minus 9, get 9, and then this is 3 minus 1, 2. So our answer is minus 29. So when x is equals to 2, the values of y is equals to minus 29. So look at question number 2. We are required to get the equation of the tangent to the curve at x is equals to 2. So in this case, you need to get the derivative. Our curve is 2x cubed minus 9 over 2x squared minus 15x plus 3. So to get the equation of the tangent, we need to get first the gradient of that tangent, or the gradient of the curve at that point. So we get the derivative dy over dx. We're going to have 6x squared, then it's going to be minus 9x, then minus 15. So that is our derivative of a curve at any given point. But we're interested with the gradient at x is equals to 2. So we just substitute the values of x with 2 to get the gradient at that point. So gradient will be 6, x is 2, squared minus 9 times 2 minus 15. This is going to be 2 squared is 4 times 6, get 24. 9 times 2 is minus 18, then minus 15. And of course, this can get us 24 minus 18. That one is positive 6, then minus 15. So you get 15 minus 6, get 9. But of course, that is minus 9. So that is our gradient of the curve at a point x is equals to 2. Now, for us to be able to get the equation of the tangent at that point, we need to know the coordinate at that point. When x is equals to 2, we had the value of y being minus 29. So we have a coordinate at that point is 2 and then minus 29. And then we get a bitter point xy, and we have our gradient as minus 9. So to get that equation, we have y. Of course, the equation is given by change in y over change in x. So we have y minus 29 divided by x minus 2. This is going to give us minus 9. So equals multiply, you get 1. So y, 1 minus is plus, so that is y plus 29 is equals to minus 9 multiplied by x minus 2. So you get y plus 29 is equals to minus 9x. You open a bracket, then minus 9 times minus 2 get positive 18. So y will be minus 9x plus 18. You take positive 21 on the other side, going to have minus 29. So y will be minus 9x, 18 minus 29. I get 29 minus 18, but of course as is minus, so we get minus 11. So that is the equation of the tangent at the point where x is equals to 2. So the third question, we are required to get the turning point of the curve. At the turning point, this is where our derivative is equals to 0. So we have at b, our derivative dy over dx, we have it here, that is 6x squared minus 9x minus 15. Now this one, we equate it to 0. At stationary point, the gradient is 0. So 6x squared minus 9x minus 15 is equals to 0. Then we solve for x so that you can be able to know where do we have this stationary point. So you can use the quadratic formula. We have our x will be minus b plus or minus square root of b squared minus 4 times a times c divided by 2a. And that we're going to have as our minus, our b is minus 9. So minus b will be minus 9, get positive 9. Then plus or minus square root of b squared, that is 9 squared. Then minus 4ac. Our c is minus, so that one is going to have minus 4 times a is 6. Then times c is minus 15. Then we divide by 2 times our a is 6. And that one would get 9 plus or minus whatever is square root, when we have minus 9 squared, multiply that one, we are going to get as 441. Then you divide by 12. So this is going to be 9 plus or minus square root of 441 is 21 divided by 12. So when x is positive, we are going to have as 9 plus 21 over 12, or 9 minus 21 over 12. So our x will be, for the case of adding, 9 plus 21 is 30. We have 30 divided by 12, or 9 minus 21, that one is going to be minus 12 divided by 12. So in this case, x will be minus 1, or by 6, 2 by 6, 5. So that is 2.5. So we have x is either 2.5 or minus 1. Then we have 2 points, so you have 2 stationary points or turning points. So you get the value of y at at x is equals to 2.5. What will be the value of y? We use our equation here of the curve. 2 times x cubed, that is 2.5 cubed, minus 9 times x squared, that 9 over 2, that is 2.5 squared, then minus 15 times 2.5, and then plus 3. So when we use your calculator, that one, you're going to get the value of y being minus 31 and 3 over 8. So the first stationary point we have, when we have x equals to 2.5, then the value of y is minus 31, 3 over 8. So that is the first one. The second one is when x is equals to minus 1. So we do the same. At x is equals to minus 1, y will be, we use our equation of the curve. So we just substitute the values of x. So we get 2 times minus 1 cubed minus 9 over 2 times minus 1 squared, then minus 15 times minus 1, then plus 3. And then when we fit that one in our calculator, we are going to get the values of y being 11 and a half. 11 and a half. So our second point of the stationary point is x is minus 1 and then y is 11 and a half. So that is the expected answer that you're required to give. Let's consider another question. Kcse 2015, question number 24, paper 1. So the questions says that the gradient of a curve y is equals to 2x cubed minus 9x squared plus px minus 1 at x is equals to 4 is minus 36. So you require to get the values of p, then the equation of the tangent to the curve at a point x equals to 0.5, and also to get the coordinates of the turning points of the curve. So start the first one. We have our equation as y is equals to 2x cubed minus 9x squared plus px minus 1. And you're told that when x equals to 4, the gradient is minus 36. So the first thing to do here is to get the gradient function. So we get a derivative. Dy over dx will be, drop that power, you get 6x squared, then minus 18x plus p. So that's the gradient function. So once we get the gradient function, we just use our x being 4. We substitute the values of x. So we have our 6 times 4 squared minus 18 times 4 plus p. This one is going to give us our gradient, which is equals to 36. And so we can multiply 6 times 4 squared, and that one is going to be 96. Then minus 18 times 4, that one is going to be minus 72. Then plus p, giving us 36. So 96 minus 72 is going to be 24, plus p is 36, and of course our p will be, take 24 on the other side to get 36 minus 24, and that is going to be 12. So our value of p will be 12. That's how to get that constant value that you are required to get. Then the other question, you are required to get the equation of the tangent to the curve at x is equal to 0.5. So first, to be able to get that equation, we have to get the derivative of the curve, and we have our derivative here as dy over dx 6x squared minus 18x plus p. Our p is 12. So once we have the gradient function, we want to get the gradient of this curve at point x is equal to 0.5. So we substitute x with 0.5. So we're going to have 6 times 0.5 squared minus 18 times 0.5, then plus 12. And this is going to give us 4.5. I'm going to get as 4.5. So that is our gradient, or you also can have it as 4.5, which is same as 9/2. So once we have the gradient, we also need to know the coordinates at which this at this point. So we have the values of x, we need to get the value of y. So at x is equal to 0.5, y will be, get our equation, which was 2x cubed minus 9x squared plus p is 12x minus 1. We substitute the values of x with 0.5. So 2 times 0.5 cubed minus 9 times 0.5 squared plus 12 times 0.5 minus 1. So once you can feed that one in the calculator, you're going to get the value of y being 3. So now we can be able to get our equation of the tangent. So the coordinate is 0.5, 3. Then we have arbitrary point xy, and then we have our gradient as 9/2. So gradient is given by shading 9/shading x, that is y minus 3 divided by x minus 0.5. This one's going to give us the gradient, which is 9/2 or 4.5. So you can cross multiply and have 2 into brackets, y minus 3 is equals to 9 times x minus 0.5. So you fill the bracket, you have 2y minus 6 will be 9x, then minus 9 times 0.5, that is 9/2, 4.5. Then get 2y will be 9x, this minus 6 goes to the other side, to get minus 9/2 plus 6. So 2y will be 9x. So 9/2 is 4.5. So 6 minus 4.5 we get 1.5. So that is plus 1.5, or 3/2. So you divide by 2, you get y will be 9/2x plus 3/2 divided by 2, you get so I'm going to be 3/2 times a half, you get 3/4. So our equation of the tangent will be 9/2x plus 3/4. So that's how you can be able to answer that question. Now we are going to look at question B. So you get to get the coordinate of the turning points of the curve. So the turning point, these are the stationary points of that curve. So our equation of the curve is 2x cubed minus 9x squared plus 12, our p we got as 12x minus 1. So to get the stationary point, number 1, we need to get the derivative of the curve and equate it to 0. So we get to have 6x squared minus 18x plus 12. That's our derivative. So at stationary point, this derivative is equal to 0. So 6x squared minus 18x plus 12 is equal to 0. And I can see all of them are multiples of 6. You can divide by 6. So that I can have an easy way. So this is x squared minus 3x plus 2 is equal to 0. Then you can be able to solve that one as product being positive 2, sum being minus 3. And look at factors that when you multiply them, they give us positive 2. And when they add them, they give us as minus 3. So that is going to be minus 2 and minus 1. When you multiply these two, you're going to get us positive 2. And when you add them, they give us minus 3. So you replace that. So x squared minus x minus 2x plus 2 is equal to 0. So you have x there, we factor out x minus 1. Then we have minus 2 there, and we to left with x minus 1 is equal to 0. So we get x minus 2, and then x minus 1 equals 0. So our x minus 2 is equal to 0, or x minus 1 is equal to 0. So in this case, you take the x minus, and you're going to have x going to be positive 2, and then you take minus 1 also, you're going to have x equals to positive 1. So at stationary point, we have two stationary points where x is equals to 1 or 2. So these are the two stationary points. Then we need to get the values of y at the two given points. So at x is equals to 1, y will be, get our equation there, 2x cubed minus 9x squared plus 12x minus 1. We substitute x with 1, so you get 2 times 1 cubed minus 9 times 1 squared plus 12 times 1 minus 1. This is going to be 2 minus 9 plus 12 minus 1. So get 2 plus 12, that is 14. Then minus 9 minus 1, that is minus 10. To get 14 minus 10, get 4. So the first coordinate is 1, 4. So that is where we have stationary point. Then the other one is at x is equals to 2. So you get at x is equals to 2, y will be have 2x cubed minus 9x squared plus 12x minus 1. So we substitute the values of x with 2 cubed minus 9, 2 squared plus 12 times 2 minus 1. So you get 2 cubed is 8 times 2, 16. Then 2 squared, 4 times 9 minus 36. 12 times 2 plus 24, then minus 1. So 16 plus 24, that is 40. Then minus 36 minus 1, that is minus 37. So you get 40 minus 37, get 3. So the other stationary point, or the turning point, is when x is 2, then y is 3. So we have these 2 points where the curve is turning. Now let's look at the last question that we're going to consider in this class. This is from the Kcse 2014, paper 1, question number 24. The question says that the equation of a curve is given by y is equals to x cubed minus 4x squared minus 3x. You have to get the values of y when x is equals to minus 1. Then you determine the stationary points, and also you find the equation of the normal to the curve at x is equals to 1. So let's start with the first one. The values of y when x is equals to minus 1. So you have our y given as x cubed minus 4x squared minus 3x. So you want to know the value of y when x is minus 1. So we substitute the values of x minus 1 cubed minus 4 minus 1 squared minus 3 times minus 1. So it's going to get the minus 1 cubed is minus 1. Then minus 1 squared is 1 times 4 minus 4. Then minus 3 times minus 1 we get is positive 3. So it's going to get minus 1 times minus 4, that is minus 5. Then plus 3, this one we get as minus 2. So when x is equals to minus 1, y is equals to minus 2. Then the second part is to get the stationary point of the curve. So to get the stationary point, we need to first have our curve is x cubed minus 4x squared minus 3x. We get the gradient function dy over dx. So we differentiate that to get 3x squared minus 8x minus 3. So at stationary point, our derivative is 0. So equate this one to 0. 3x squared minus 8x minus 3 is equal to 0. This one you're going to get as, can have the product here. 3 times minus 3 is minus 9. And the sum is minus 8. Look for factors, the numbers that when you multiply them, they give us minus 9. And then they give us minus 8. So that one is going to be minus 9 and positive 1. So minus 9 times 1 is minus 9. Minus 9 plus 1 is positive 8. So you replace that one with the 2. So 3x squared minus 9x plus x minus 3 is equal to 0. So we factor out x, 3x, x minus 3 plus 1, x minus 3 equals to 0. So we take 1, x minus 3, and 3x plus 1 is equals to 0. So you have x minus 3 is equal to 0, or 3x plus 1 is equal to 0. So this one, x will be 3, or in this case 3x is equals to minus 1. Take 1 on the other side will be minus 1, and this one is good to divide by 3. X is equals to minus that. So you have x is equals to 3 or minus that. Those are the 2 points where you have the values of x when we have the stationary point. Now we need to get the points. So at x is equals to 3, what will be the y? So at x is equals to 3, y will be our value there is 3, x will be 3 cubed, then minus 4 times 3 squared minus 3 times 3. So 3 cubed is 27, minus this squared is 9 times 4, 36, 3 times 3 is 9. This is 27 minus 36 minus that is minus 45, and that one we're going to get as 45 minus 27. Minus is minus, so that 15 minus 7 is 8. This one is going to be 3 minus 2, 1. So this is going to be minus 18. So the first coordinate is going to be 3 and then minus 18. Then the other one will be when x is equals to minus that. So at x is equals to minus that, y will be, get our y here. So it will be minus that cubed, then minus 4 times that squared, then minus 3 times that. So minus that cubed is going to be minus 1 over 27, then minus 4, that squared is 1 over 9 times 4, get 4 over 9, then minus 3 times minus that, you get positive 1. So you get minus 1 over 27, minus 4 over 9, then plus 1, and that one is going to give you as 14 over 27. So the second coordinate at the turning point or at the stationary point is going to be minus that at 14/27. So those are the our stationary points of that given curve. So let's look at the last question, number C. We are required to get the equation of the normal to the curve at x is equals to 1. So the first thing that we are going to do here is that we are going to have our equation, we are given there, y is equals to x cubed minus 4x squared minus 3x. And we are required to, first thing here, we need to get the derivative. So dy over dx we are going to have as 3x squared minus 8x minus 3. That is the derivative. After that, we need to know the gradient at x is equals to 1. So at x is equals to 1, our gradient function will be the dy over dx. That is, our gradient function will be 3 times 1 squared and minus 8 times 1 minus 3. Then I'm going to have 3 times 1 squared is 3 minus 8, then minus 3, then 3 minus 8 minus 3. That one I'm going to get 3 minus 3 is 0, so you're going to be left with minus 8. So that's our gradient of the curve at x is equals to 1. And what we know is that this one is a gradient of the tangent at that point. So a tangent at the normal are perpendicular. So to get the gradient of the tangent, we need to have the m1 times m2 is equals to minus 1, because perpendicular line, their gradient, the product of their gradient is equals to minus 1. So to get the gradient of the tangent, we are going to have now minus 8. You multiply by the m2, you get minus 1. So you divide by minus 8 on both sides, and then you divide by minus 8 on the other side. So we are going to have our m2 we're going to be positive 1 over 8, because minus 1 divided by minus 8 is going to be positive 8. So this is our gradient of the tangent of the normal. So the normal gradient is 1 over 8. So now we have the gradient of the normal. We need now to know at this point x is equals to 1, what is the value of y, so that we can be able to know the coordinate at that point. So we are going to take our function, which was y is equals to x cubed minus 4x squared minus 3x. At this one, we are going to replace the values of x, or substitute the value of x with 1. So we're going to be having 1 cubed minus 4 times 1 squared minus 3 times 1. So we're going to be having 1 minus 4, then minus 3. So 1 minus 4 minus 3, I'm going to get minus 6. So when x is equals to 1, our value of y is equals to minus 6. So our coordinate at x equals to 1, we have 1 and then minus 6. So this one, we have our gradient as 1 over 8. and then we have our xy. So now what we need to get is the equation. So the equation, of course, will be change in y over change in x. So you have y minus 6 divided by x minus 1, which is equals to 1 over 8. So we cross multiply, we get 8 into brackets y minus get plus 6 should be equals to 1. You multiply by x minus 1, and of course 8 times y, you get 8y plus 48, that is 8 times 6, should be equals to 1 times x is 1x, then 1 times 1 is 1, and then after that you get to have 8y will be equals to, we take 42 on the other side, so you get x minus 1 minus 48, 8y will be x minus 1 minus 48, you are going to have minus 49. So you leave it in y is equals to mx plus c. Y will be 1 over 8x minus 49 over 8, and of course you're not going to leave this one like that. The final one will be y is equals to 1 over 8x minus 6 and 1 over 8. So that is the equation of the normal. Thank you.